Hi everybody, welcome to the Manifold channel. Today we're going to do the third video in our series on the new join dialog, and what we're going to do is a raster to vector join. Now a lot of people think of joins as something that's done from table to table, where you're adding a new field to a table or you're modifying, updating a field from the table based on data from another table. And all that's cool, but when you're doing a spatial join, for example like an overlay in Esri, or when you're doing another type of join, like when you're doing a raster to vector operation, as many GIS packages have special dialogues where you can take particular data from a raster and say, pick the height out of this train elevation raster under each point and put that into the point as an attribute. That too is a type of join. Everything in Manifold, ultimately way down where, is a table, so we can do also all those sorts of joins using the same orthogonal framework, the same speed, and the same parallelism. What we're working with here is a Manifold System Release 9. That's what we're looking at right now. And the way we have this project laid out, it's kind of a weird layout because we have to film this in a relatively limited space. When you're working with a full-size monitor or 2 or 3 monitors, you can lay out all these tables all sorts of different ways. You don't have to scrunch them up in these small format tables that we have here. And what we have here is a map, and the map has 3 layers to it. There's a terrain elevation raster, which is this raster right here in the project. And that takes its data from this terrain table, and you can see how raster data is typically stored in Manifold. These can be huge tables. These, they're composed of tiles for efficiency, and there can be 200 gigabytes in one of these, and it'll display just as fast as what you see right here. And I just wanted to show you what that actual data looks like in that table. We're going to turn off that table, now we also have a points layer in this map, and this is the points table right here with the attributes behind those points. There's no real attributes for each point. What we want to do is add a height field here, where the height is going to be taken from the pixel, the raster pixel that's underneath each individual point. And we also have a parcels table here for our parcels layer, which we'll use later on in this demo. We'll get to that in a bit. But for now, let's take the height from from the terrain elevation surface, which is a terrain elevation in the vicinity of Livermore, California, and we're going to add that as a new attribute to this points table. So with the focus on the map, the points table is points layer is what we've selected. And let's click join, and here's the join dialog. So we want to use as the joined data bring it in from the terrain raster, and we want a relationship where the geom contains the tile, that is the geometry under each of these points, whatever pixel is contained in within that tile. So let's add a field. The only field that is available in the terrain is channel 0, so it's a single channel raster, and we're going to give that a more sensible name than channel 0. We're going to call it the height. And since there's only one pixel under each sample is a sufficient method to use. It just basically takes the first value it hits in channel 0 and puts that in the height. I'm going to save the update query so we can modify that later if we want to rerun the operation in a modified form. And click join component, and right away that adds a height value, and it takes that height value from the underlying terrain. Manifold computed that in parallel. This is a tiny data set, so it doesn't matter. But it will automatically launch and do all this stuff. If you have a 12-core CPU, it'll do all that with 24 threads. So it's still lightning fast, even if you have like 1 billion records. It's just amazingly fast at stuff like that. Okay, we've added the height thing here, and you can see we have a lot of decimals after the decimal places after that it's used, and the tooltip will show the value. It's a floating point value because that's what the terrain elevation data set uses. Suppose we wanted this to be rounded. That's easy enough to do. We take the query here. Let's double click it open, and I will undock that so we can work with the query. And what I want to do is here's the operative thing where it selects. It does tile geom sample terrain as S0. As you can see, this is an SQL query that you'd use for just about anything else to do a join. And the way these joins work, since it's pretty much the same query that you use table to table, if you have a specialized function that grabs the the data that you need from whatever the data set it is, be it a raster or a vector or whatever, or a table, it automatically grabs it and it works. And so we can run this basically using the same SQL that we do anything else, and we can modify that using the same SQL. So, example, let's use the round function here. Put round parentheses there and parentheses there. We've just done is in case what was a floating point value that's returned by that expression, and we're going to use the round function to round that to the nearest couple decimal points. And I've just rewritten the query. I've updated it right here. I'll close it. And so what I want to do, so I want to run that, I just click there, run. And you can see height immediately changes to that value right there. It's that easy to modify queries and to rerun them. And why might we want to rerun the update query? Well, suppose we added more points. Suppose the terrain elevation changed, something like that. rerun the query, and it does this. This data is actually copied from the raster into this points table, into the vector attribute for that layer. Super. So we've just worked with points. This works with all types of area objects. So we have different objects here, like if we had lines, if we had areas, we can do that. I'm going to turn off the, no, let's leave the points table turned on. Let's go here to the parcels layer, and I'll make the parcels layer the active, and I'll turn off the points. And here for the location, I'll jump to the parcels location. So these are the various so-called parcels. They're just areas that I made up, and they're shaped the way they are because that was just a convenient way to make them look pretty. And this layer is shown with partial transparency, so we can see bits of the train elevation data set underneath that. What I'm going to do is I'm going to add 3 fields to the parcels table right here, and here's our parcels table. Let's expand that a little bit. And what I'm going to do is I'm going to add an average height field. I'm going to add a maximum height and a minimum height to give me the average height, the maximum height, and the minimum height under each of these rhomboids, each of those areas. So once again, with the focus on the parcels table on the map, I'm going to click Edit, Join. And here, let's once again, let's choose the terrain elevation as our source for data. And let's start adding fields. We're going to add channel 0, and the first one we're going to call average height. And for that, I'm going to double click into the method. What I want to do is I want to choose the average, because there's now many pixels under each of these fields, so I want to choose the average of those pixels. Let's do another one, which again from channel 0, which I will call max height. I'm just following along the user manual example, by the way, if you want to do this at home. And I'm using the same names. And for that, I'll choose the max function, the max aggregate. Now I'll add another one, channel 0, and let's choose min height. Let's rename that min height, M-I-N-H-E-I-G-H-T, and double click here to choose minimum. There. And let's save the update query as well, just in case we want to modify that. If I click join component, bang, like magic, all that's added. And once again, if we want to look at the the parcels update, here's the update query that we saved. Double click that open and undock it. And now you can see how all these look. If I want to round those, let's add round to that, all those as well. R-O-U-N-D. And let me Control-C to copy, Control-V to paste, Control-V to paste, and then here I want to add a parentheses. And close the parenthesis here. Close the parentheses there. And now we're going to have the rounded version of this query. That looks good. I didn't do any typos, did I? Nope. Okay. Let's see if I messed that up or not. Click Run. Nope, I didn't mess it up. So you can see that immediately rounds that down. It's that easy to do raster to vector joins in Manifold. There's a whole lot of stuff in that join dialog. It's just unbelievably easy and flexible to use. One of the nice things about it, if you want to learn SQL, is that since it writes those queries for you, you can see how that's done if you then want to later use extremely involved and complicated SQL queries. But the dialog is so easy to use that for most work that you do, most work that people do with, say, overlays and stuff like that, and any kind of table joins and a whole lot of raster to vector operations are very easily done in the join dialog. Even if you're an SQL wizard, you're going to find yourself using that dialog over and over and over. It's that convenient and that quick and fast and easy to use. I hope you've enjoyed this video. Thanks for watching, and goodbye from Manifold Land. Well, that was fun. If you want to see more, visit us at www.manifold.net. As always, Manifold delivers the world's most advanced, highest quality spatial products for GIS and DBMS at a low price that you can afford. Once again, that's manifold.net. See you soon.